Hello and welcome to episode 174 of our SAP on Azure video podcast. Today is January 11th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So welcome to 2024. This is our first episode in the new year, and I'm really looking forward to what's coming in the next months. We do have some upcoming changes in our podcast, but we will talk about this at a later time. For now, I can tell you that we have some really cool content planned for this year, and of course also covering some of the AI topics that everyone is talking about. For today, I'm happy to have one old and one new guest for our show. Martin Raepple has been here several times before, and today he's joined by Bastian Ulke. Both of them have worked on an architecture to expand SAP Digital Manufacturing with Azure. So let's dive in right away. Maybe Martin, Bastian, maybe you can quickly introduce yourself, what you do at Microsoft, and then we can see what you have prepared.
Thanks, Holger, and hi everyone. I'm a recurring guest here in Holger's and Goran's and Robert's podcast. Happy to be here again. I'm with Microsoft since more than 4 years now in different roles. Started as a cloud solution architect, now a technical specialist for Azure infrastructure, and responsible for many of the integration topics between SAP and Microsoft. And I will enjoy today talking together with Bastian about a very interesting scenario regarding an integration scenario for SAP and Microsoft. Now, over to you, Bastian.
Thank you very much, and thank you, Holger, Goran, Robert. Thanks you very much for having us. Yes, so my name is Bastian. I have been working with Microsoft for Microsoft as a cloud solution architect for more than 2 years now. Before I joined Microsoft, I had different roles also in the manufacturing industry. So this is quite exciting, and therefore I'm also very happy to have this opportunity today to talk with you and Martin about what we have developed in the last months.
Cool, perfect. So Bastian, I think you had you can give us a first overview of what the scenario is, what the idea of the integration, the extension basically is.
Yeah, exactly. So basically what Martin and I want to talk with you today about is how we integrated the SAP Digital Manufacturing solution with our Azure services for custom vision. And for those of you who do not already know SAP Digital Manufacturing, that is a solution that allows customers to build a manufacturing execution system to control processes that they are running on their shop floor. We might also call this just for brevity SAPDM in that presentation. So if you hear that abbreviation, it's going to refer to digital manufacturing. Now we all know every customer is different, right? So, of course, SAPDM will allow customers to customize the processes that they are running on their shop floor. However, as you can imagine, they might easily also run into a situation where they would like to retrieve some input from external systems and also integrate that and use that when they are controlling their processes. And one exciting example that I have come across quite some times in my past is to integrate MES systems also with services for visual inspection. That is, take a photo during the process, then analyze it to extract some information from that picture and use these insights to decide if you want to go left or right from where you are in this process execution. And this is where we have a perfect match with the services that we offer on our Azure platform, right? So what we are going to show you today is how we can use Azure Custom Vision services to integrate this with SAP Digital Manufacturing to enrich a production process, which is implemented there. And we were lucky enough to work with some colleagues from SAP also on that implementation, and also got the sample data that you will see in that presentation from them. So big thanks and big kudos also to them.
Cool.
Martin and I have started working on a blog series about that setup, and that's going to also provide much more details than we will be able to cover today, I guess. So maybe, Holger, we can also link that somewhere when we publish that video. I think that would be great and very helpful for our listeners.
We'll definitely do that, yeah.
Great. So let's get started. Martin, will you be able to bring up the slides that we prepared?
Absolutely. All right.
Great. So, of course, we start in the SAP Digital Manufacturing. So that's the box that you see here in the upper left corner. SAP DM offers a view that is called the production operator dashboard, and that will always serve as the user interface to the user. Now let's assume we are in a process step where we have a product assembled and we would like to use the visual inspection to verify that this product got assembled correctly. Martin, if you could click. Therefore, we have installed a camera in the production line, what you see here on the bottom of that picture. And that camera will allow us to take a picture of the assembled item and use that in the next steps of our processes. Now, if you take a close look at that picture here, you see that there is a screw on the right side of this item that we see here. Maybe you can point to that one with the mouse. Yeah, exactly. On the right side, there is the screw. On the left side, that's missing, right? So here on the left side, we've got that hole where the where that item is actually missing a specific screw. And I mean, as you can imagine, this might end up in a major quality problem for the end user if we ship that product as it is to the end customer, right? So what we want to do is to basically enrich the production process that we implemented on SAP DM and show a message to highlight that there is something odd in that setup, and that this specific item here requires the attention of the production operator, sorry. So what we want to do is to take that picture, send it to a visual inspection service, and have that one analyzing the picture to detect and locate the defects for us, and then use the results in the process that we implemented as part of SAP DM. So I think, Martin, if you could click once here, yeah, great. So in that setup, we have, for that setup, we have deployed an instance of the Azure AI Custom Vision service. This is what you see here with that icon that is representing that cloud with these circles and lines. And in that custom vision service, in that instance, we have already trained a model with a stack of sample pictures that we tagged to make the service learn how a missing screw actually looks like. So now, when
Bastian, is this custom vision service actually a Azure cloud service already existing for this purpose?
Yeah.
Okay.
Yeah. So that is a platform service. It also offers a nice user interface, so you can deploy that into your Azure subscription. Then you got some interfaces, technical interfaces that you can use for programmatical integration, but also a user interface in which you can upload the pictures, tag the pictures, and train the model. Yeah, and then you can use it for integration with further services.
And we will also show that in the demo in a few minutes, how to train such a model, how to create such a model. Yeah.
Cool. Yeah.
And in that context here, of course, we now take that picture that you see that we have already seen, and we'll submit that camera picture to the model, and the custom vision service here will respond to us and provide us with the details about if and where it sees a missing screw, obviously, right? And that information we will now eventually have available in SAP DM to use it for the further process execution. So we can, for example, display a notification in the user interface, attach the inspection results to the metadata that we have stored with that item, and use it in the remainder of that process.
Oh, nice.
Make sense? Any questions?
Absolutely, yeah.
So that's basically the idea, right? And of course, as you can imagine, it's not just a two-click deployment, but it requires some work to really to integrate these pieces and make them work smoothly together. And I think this is where Martin gives us a very good overview about the architecture and also about how we deployed it, actually made it work.
Okay, so thanks, Bastian, for the overview about the scenario. I hope you won't get frightened seeing this detailed picture.
It's a little more complicated.
a little bit more complicated. So we are now diving a little bit into the details. So, but don't be afraid. I won't go into all of the details of this picture. However, I just want to basically let you understand, or hope to give you some understanding of the basic building blocks of the picture. Again, so on the left-hand side, you see essentially the components from SAP Digital Manufacturing, which from a customer perspective, an SAP customer's perspective, is a subscription in a SAP Business Technology Platform sub-account. In that sub-account, you need an entitlement for subscribing to the SAP Digital Manufacturing solution. That gives you essentially then access to a digital manufacturing tenant with all the applications that are part of that solution that allow you to customize your digital manufacturing tenant. And one of these components is the production process designer. This is the place where you exactly design these integration scenarios with external solutions such as this custom vision service on Azure. And we will take a closer look at this piece in digital manufacturing at the production process designer in a minute. Obviously, in order to enable communication and especially also consider security in this communication between digital manufacturing, the digital manufacturing tenant on the left-hand side, and the extension built on Azure on the right-hand side here, you need some authentication and authorization. So you want to definitely not allow everyone to consume the service on Azure to analyze this picture, but only your specific instance of the digital manufacturing tenant on the left-hand side here. So for that reason, what we propose to do here in our architecture is to register an application that represents an application in the associated Entra ID tenant that's associated with your Azure subscription, where you deploy all the resources required for the extension, and register an application that essentially represents the digital manufacturing tenant on the Azure side, and register or create also a client ID and secret that allows the tenant to obtain an access token from the Entra ID tenant that can be verified on the extension side to essentially check or verify that only an authorized system or an authorized component, in this case here, this production process, is allowed to call the extension and consume the service and analyze the pictures. Yeah, so that not everyone can call this endpoint. On the actual extension side, so to the main components are an API management instance that we propose to set in front of the actual implementation of the business logic for the extension, simply for the reason to first of all to declaratively configure the validation of the access token, for example, using API management policies as part of the API management solution in Azure, but also to ensure governance on the interface, on this external interface between SAP and Microsoft, and maybe to also ensure other non-functional requirements, such as, for example, throttling, rate limitation of the calls that are allowed from the external consumers, etc., etc. Yeah, so API management definitely suits you very well into this architecture because it allows you to declaratively protect and shield the actual implementation of the extension by exposing the only external endpoint in this picture, a public IP that certainly is required to allow communication between SAP and Azure. But as you can see in this picture as well, we make extensive use of private endpoints to ensure only a communication over the internal Azure backbone between those components. So essentially everything that or all communication that goes or beyond the API management is only goes via private endpoints. Yeah, so communication from the API management gateway to the business logic. We implemented the business logic of the visual inspection extension using Azure Functions. However, you could also choose another runtime service, or like, for example, you could use a containerized workload here on Azure, for example, to implement the business logic. You could use even up to a Kubernetes cluster here. So whatever you think is the right approach and runtime that fits your needs here will work. We propose here to use Azure Functions as they are very convenient and definitely a good way to implement this solution. As you can also see, we separated the whole business logic into individual services or microservices that take care for a specific piece of the business logic. The first Azure function implements a microservice that takes care for receiving the request from digital manufacturing. So the picture that we saw in the previous slide that Bastian explained, yeah. So the picture that was taken from the camera and sent over to Azure for the inspection. That function then stores the picture into a blob storage. Again, only communication via private endpoints here, so no public endpoint of that blob storage is available for security reasons. Then triggered by the production process, by the second step of the production process, the actual analysis of the picture is taken care by the second function here in the picture. So once the picture is stored here, the second function here takes care for analyzing it. Again, it puts it here into a event hub queue that triggers a third function that actually sends the picture to the AI service. And after that, after the results are ready from the Azure AI Custom Vision service, the results are again posted into a event hub queue that triggers then the fourth function here fourth microservice to publish the results. So the indication of the missing screw, for example, if one was found, and sends them back to the public API of SAP Digital Manufacturing. This is the inspection log API that is used, which is described also in the API Business Hub at SAP, where you essentially can send results from such a visual inspection extension back to digital manufacturing in order to show them in the visual inspection production operator dashboard POD, and from there then continue in the manufacturing process. All right, so
Martin, how is the authentication? Yes. I mean, this is obviously an asynchronous process then. So.
Oh yeah, very good that you asked, Holger. Exactly. Yeah, it's an asynchronous communication. So yeah, so the very first call that essentially in our sample scenario here takes the receives the picture. So we have to, since we don't have in this demo setup a real industry camera, what we actually do is we simulate this first step in the process with an kind of a
like a mock
picture
service,
of
basically.
a mock service, right? And when the second step in the production process sends that mock camera picture to our analysis service, it also always goes via the API management gateway, but it immediately gets back a HTTP 204 that essentially says, okay, so I got the picture, but processing of the picture will and the response with the results will happen asynchronously. Yeah.
But then, once the image is analyzed, then there's this callback or this this last flow. And there, how do we do the authentication on this side? Did we need to do a similar setup like when calling the Azure API management?
Exactly. So essentially, we have the same sort of credentials that we use for the communication from Azure to SAP using these so-called OAuth client credentials grant. We have the same type of communication credentials back to the to this inspection log API. So this is protected by a so-called service key that we got from the Access UAA. So a service instance of the Access UAA service from the BTP sub account where the digital manufacturing tenant is. And with these credentials, we need to, and these credentials are stored actually in a key vault. So we use the key vault service on the Azure side to store. Well, we use it also for other confidential information in this scenario, but mainly for such type of credentials that require confidentiality. So when this fourth microservice sends back the results, it obtains a token, an access token from that Access UAA service instance. In order to do so, it needs the client credentials that it can retrieve from the key vault, again, only using or only via private endpoint and using a managed identity that represents the Azure function and authorize that Azure function to key vault in order to obtain these credentials here. Right. Okay, and with that, maybe let's go quickly into these spots highlighted here in that diagram. So maybe let's take a first look into the production process designer and how that looks like. Let me go quick. Okay, so here we are in our digital manufacturing tenant, and let me open the process designer. Again. Here we go. Okay. So this is the deployed version of our production process, and I mean it only contains right now these so it's only these 4 steps. So start point and end point, and the 2 steps. So the first step, as we said before, it simulates the retrieval of the camera picture. So again, what we don't have a real camera that interfaces with this step in the production process. What we do, as shown in that slide deck and in the solution architecture, it actually retrieves the camera picture via a service on Azure that reads that picture and encodes it into base64 encoded JPEG data, and it retrieves it from the blob storage. But in a real world setup with a camera installed on a production line, those cameras typically also have an RESTful interface to take a snapshot of the current camera picture, and then that step would interface with those devices using the APIs that are offered by these devices. Again, what we do in this demo setup here is we simulate that camera, and then the picture is essentially taken here from or sent further to that second step here in the process. And as you can also see here from the settings, this step, as well as the first one, by the way, they both refer to a destination. And the destination is a destination in the sub account of the in the business technology platform sub account for that tenant, and we can also quickly take a look at that. And again, my session has timed out, and I need to log in again. And all right, so here we are already in that sub account where this this digital manufacturing tenant is subscribed to. And if I look for the destination that we just saw in the manufacturing in the designer for the production process, we see that this destination is configured using authentication or through client credentials. It has a client ID and a non-readable client secret. And this is essentially registered in the port, also on the Azure side as an application in our tenant. Okay, so if we go into our Entra ID tenant, we will see that there's an application registration for the digital manufacturing tenant. That has exactly the same client. So that has this client ID 944, etc. that we saw here in the cloud cockpit, right? So 94. So, and the secret obviously needs to be registered here as well, and that's done here. So yeah, I've registered also one for testing purposes for Postman as a client, but essentially that's the secret. By the way, our GitHub repository that comes along with our blog post regarding this scenario contains all of the Terraform infrastructure as a code scripts that will set up this whole infrastructure that you see here. And it also takes, and by the way, that's a very nice, I think a very nice scenario for Terraform, being a multi-cloud infrastructure as a code tool, right? Because what it does essentially is it takes care for registering the application for the visual inspection scenario here on the Entra ID side. It also takes care for creating the service key, and then also makes sure that the destination is created using the client secret and ID generated here by the Entra ID tenant, as well as storing the service key into the key vault. So everything can be automated fully end to end with Terraform, and I think that's a really nice, a very nice scenario to show how powerful Terraform can be, especially in such a cross-platform scenario.
That's actually really cool, because at TechEd, we had exactly a hands-on session on this, where we talked about how you can use Terraform cross solutions. So not only using Terraform on the Azure side, but also using Terraform on the BTP side. And that's a beautiful example here.
Yeah, exactly. Yeah. So let me see if I can quickly go. So once, if you are, as I said, if you're interested in setting up this scenario and getting your hands dirty, please do so. We have prepared here, along with the blog posts, an up-to-date GitHub repository, and in this subfolder infra you find all of the Terraform scripts that essentially allow you to, with one run of these scripts, to create the whole picture that we saw in that slide deck. Okay, so let me go back to, so we saw now the communication with the destination and the setup with the destination. Now let's take a quick look at the custom vision service, as mentioned before. So the custom vision service, being part of the overall Azure AI services, allows a business expert who knows how to train the model, with a very, let's say, convenient tool. That's this custom vision UI here. And let me also quickly log in here. And as you can see, we've already created, so you can create different projects. Typically, I think those projects will be associated with the different scenarios. Now with this scenario of this wolf head with these three screws, we, as Bastian mentioned, we received this training material from the colleagues from SAP and used these sample pictures to train the model and to create the model. And you may also notice, and that's by purpose, that these training pictures that you see here, and you should, I think, at least use 30 or 40 in order to get a good quality of the model. They all come partially they were all taken with partially different angle, and maybe, as you can see, the color or the lighting sometimes changes. So that's all by purpose, because the camera and the lighting conditions in a real world scenario also won't be equal for each picture taken by the camera, right? So that's why you typically ideally have training material that has slightly different positions, angles, etc. And as you can see, we have also pictures that where the screws are missing at different places. Yeah, sometimes it's the top one, the left one, right one, sometimes the bottom one. And if we click on one of these pictures, you see that we went through the process of marking the place where the screw is missing in each of these pictures. Also assigned a tag, the missing screw tag. Yeah, you can freely choose whatever you want. Yeah, but this is the tag that also the model then, or the business logic and the functions are looking for. And if the Azure AI service responds with an indication that it indicated a missing screw in the picture, then it will return exactly that tag to the business logic. All right, so that is the part for the maybe one last look at the Azure functions. As you can see from that picture, we are using in total 4 functions. So we deployed an Azure function app that where those 4, and by the way, all of the C# code is also included in the GitHub repository, and we have and let's maybe just open 2 of them here in our to trace the logs, because now we go into the demo. So we now simulate taking a picture from the camera, send it over to our extension built on Azure, and then see how the results are. And just to verify that the whole end-to-end flow works, we go into we open 2 of these functions. Maybe I want to actually go into this one. So that's the function that sends the final results of the analysis back to SAP Digital Manufacturing. So we open that and look into the logs, into the live logs here, and this function, and maybe move that a little bit here to the left. This is the function that picture analysis. Okay, sorry, I actually wanted to open a different one. So the picture analysis processor, right? That's the one that sends the picture to Azure AI services and gets back the results. Okay, with that, maybe let's go back to our digital manufacturing tenant and go into the visual inspection production operator dashboard. Okay, and now we are essentially in the role of this production operator who has to deal with these quality issues. And here we see a list of so-called SFCs, which stands for shop floor controls in digital manufacturing. Those are essentially partially, or those are individual products manufactured according to an order that typically is received in digital manufacturing, for example, from a connected S/4HANA system. Yeah. So, and as we can see, some of them are already in that inspection step. but some of them, so those are those marked here as status active with this green box here. Those with the blue box are still in the queue of going through this inspection step triggered by the production operator here. Yeah? So what we can do now here is we can essentially mark one of these shop floor controls here, these SFCs in the list, and trigger the visual inspection process by clicking that start button. Again, these production operator dashboards can be customized. That's part of the digital manufacturing solution. So each of these buttons can be configured, and we configured this production operator dashboard in a way that when you click on that start button, this production process that we saw before in the designer is essentially then triggered, yeah, by that click of a button here, yeah, with the selected SFC. So we start the process, and then we get an indication here that for this BRP, for the selected one, the inspection step has started, and as you can see, the status turns into green. Now maybe let's take a quick look, and as you can already see, there has already been some action on the Azure side for processing that request. Yeah. So that is actually already the second or the third function or microservice in our overall extension solution that took the picture from the camera, sends it to Azure AI and to the custom vision service and let it analyze by the model. And somewhere here we should also see that the result, if a missing screw was detected. I mean, essentially it's sent back here in the response by the fourth function in our step. And as you can see, it's a JSON. Yeah, it's a JSON format that's defined by this inspection log API from Digital Manufacturing. Yeah, so it's publicly documented by SAP how the response has to be structured and look like in order to get processed by Digital Manufacturing. So there's a specification about the JSON format, and part of that specification is essentially that you send over a known tag in digital manufacturing. This is this missing screw tag, a prediction score, which essentially says how confident is the service on the Azure side that there is a missing screw. So as you can see, it's a value between 0 and 1. Yeah, so 1 means 100% confident. Yeah, so obviously our model on the Azure AI side in this case is really confident, yeah, because it's nearly 100%. Yeah, and it also sends back, as you can see here, the coordinates of the bounding box, for in the picture. Yeah, so when you send these coordinates, then you should also see in the production operator dashboard, the corresponding visualization. So let's go back to the to this production operator dashboard and click on visual inspection. Here we go.
Perfect. Yeah.
Okay. Yeah. So as you can see, we nearly saw that 100% precision value in the response. So that's what is also shown here. And now I, as an production operator, can still decide. So that's why it says here manual mode. Yeah. So it's essentially not a decision fully automated by the by this visual inspection logic. Yeah. On the Azure side. So it basically gives the operator a clear indication about the confidence, of that issue. However, you as an operator can still decide whether or not you mark that SFC as a conformant or non-conformant piece. Now, speaking of next steps for this scenario, what we also intend to demonstrate here, which is right now not built into the whole flow and logic, is that, let's say you as an operator decide that this is a false positive. So you decide that, okay, you essentially mark this as conformant, although the model might have indicated that there's an issue. Yeah, this could also be the case. Yeah, so the model might fail. Yeah, or the artificial intelligence might fail, and that's why then you need to maybe overrule the decision. And in such a case, you probably also want to improve your model, right? So you, in this case, you probably want to say, okay, here the model failed, so it made a wrong decision or a wrong indication, and you want to retrain the model then with that decision that you made here in the as an operator. Yeah.
So would that happen automatically, like retraining of the stuff with the?
Exactly. That's exactly one of our to-dos on the next step too. Now, so as I said before, these operator dashboards can be highly customized in digital manufacturing. So you could also decide what to do if you click on that button, depending on the context. Yeah. So let's say you have such a likely non-conformant SFC, but you click on conformant, then you could, for example, again trigger another production process or call an API that retrains the model with the decision made by the operator here. Exactly. That's what we also plan to do is to further extend the scenario in a way that it allows the operator here and to automatically then in the background to improve the model so that that the false positives get lesser and less. Yeah. All right. Yeah, with that, I think we are through that picture and also through the demo. Maybe as a last comment, as we said before, there is a set of blog posts that come along with the overall scenario that also explain exactly what you need to do if you want to build your own test environment for this extension scenario. And Bastian and I thought it makes sense to start with this whole topic by taking a step back actually from the actual scenario that you are looking for, such as a visual inspection scenario. It may be something completely different, right? So there are definitely more than only visual inspection extensions possible for digital manufacturing. And that's why we published a blog post that first describes a general reference architecture for these
Super.
I don't know, Bastian, any further comments here on our reference architecture?
I think there are a couple of fixed services that we would anyway recommend, right? So like, for example, doing the proper authentication using Entra ID, of course, not going with some secrets, but relying on OAuth, for example, having the API management in front of that. And we would also probably recommend to go with an event-driven architecture. This is why you see the event hubs here on the right side, where when it comes to the extension themselves, what you see here in the center of the right box, I think there we have a lot of flexibility, right? We decided to go with Azure Functions here, but at the end of the day, it's up to you to decide if you want to go with, if you want to go with a virtual machine implementation because you have some legacy services that you want to integrate with digital manufacturing, if you want to go with a full-blown Kubernetes cluster or whatever. So that's up to you. We decided to go with Azure Functions because that made pretty much sense in our use case. But I think basically you're open to do anything here as long as it exposes a REST service and it makes your services available using API management.
Yeah, exactly.
Okay. I have one question. So when we are talking about manufacturing, so if you have some manufacturing line, that manufacturing line has their own speed, so you need to somehow keep that speed in some frame, so you cannot go below, you cannot go faster, and also the digital manufacturing for SAP is creating some business scenarios to satisfy that. So what is your opinion on top of how you can guarantee that you don't introduce extra latency in all those processes, so that you can control it. Of course, you can always take on Azure side biggest queue, or you can switch to containers that have most flexibility for multiple nodes and so on and so on. But what is your thought about that?
Yeah, definitely. That's a very, very good question. Maybe I can quickly start. So again, looking maybe back at this picture here, there are definitely a number of places in this picture where you could, let's say, scale up and down depending on your performance requirements, right? So API management can be scaled up and down. Certainly, depending on the choice of runtime, as Bastian just mentioned, yeah. But for example, if you decide to go with functions, yeah, those can also easily scale up and also down. Yeah, I mean, we also need to consider downscaling, right? The same is true for your choice of the event management. Yeah, if you go with event hubs, yeah, again, yeah, there's certainly also options here to scale up and down. So I think, depending on your performance and real-time performance requirements, there are plenty of points here in that architecture that allow you to react to those. However, I agree. I mean, in the end, you depend at the interface between BTP and Azure, right? I mean, we go over the internet, so we have a cloud-to-cloud integration scenario, and I see absolutely that point that this might be a concern, yeah, maybe less from a security perspective because everything is here highly encrypted, and again, we took care for authentication and authorization in this scenario, but this can be an issue. So SAP actually offers also an edge solution for digital manufacturing. It's called SAP Digital Manufacturing Edge. It exclusively runs on the Azure Stack Edge appliance, and customers that are concerned about those latency issues can decide, yeah, to deploy these edge instances in essentially close to the production line, yeah, in the plants. And we are also talking about outlook of future topics that are very interesting in this scenario. So Bastian and I, together with the SAP team, want to also look into scenarios where the extension actually runs on the edge. So not on the cloud, but on the edge, yeah. So that it's really that you don't have any latency, yeah, between the production process and the execution of the extension. So that, for example, the camera picture, yeah, again going back to that visual inspection scenario, the camera picture will be sent to an edge device that sits more or less next to the camera, right? Can be analyzed on the edge with an Azure AI service instance deployed on the edge, yeah. So also no communication to the cloud, and the results are directly sent back to the product. Yeah. So, but that's something again we want to take a closer look as a next step. Exactly. Yeah.
I mean, you know, I go with I start with that question because exactly with what I expected answer from you, because I think this is another example of power of cloud. You know, you see, you present that there's options to extend that, there's options to modernize that, and this is, I think, much better than classical closed solution. So you always have a chance to extend that. You always have a chance to improve it, yeah, and not change complete architecture and buy new licenses from something else and so on. So you're just extending, modernizing, fitting the gaps and so on.
Yeah.
Nice.
I mean, this is nice because there's always, you have a lot of boxes, but they're already prepared. You just combine them, you know, like a Lego. I guess you had very less code probably in those Azure functions as well, just a little bit, I suppose. But generally, it's combining the boxes to build a Lego castle, so to say, more or less, which is a great.
Yeah.
Cool.
Cool scenario.
Martin, Bastian, yeah, thank you so much. I think there was a really interesting introduction, and I'm already looking forward to the follow-up when we then talk about the edge integration, and then when we talk about how this works on premise with even less latency. So I hope we can have you back at that time when it's done.
Definitely.
Sure. It will be our pleasure.
Right.
Perfect. Thank you very much, and see you next time.
Thank you.
Thank you.
Bye-bye.
Take care.
Bye-bye.
Bye-bye.